Langchain Prompty Utils Run Summarization. A utility library for interacting with langchain and Prompty. This library provides tools and methods for integrating langchain models with Prompty, enabling the creation of powerful text processing workflows. Langchain is a powerful framework for building and interacting with large language models, while Prompty is a Python library designed for automating and simplifying the process of building conversational interfaces and chatbots. The library aims to streamline the process of using these two tools together by providing pre-built components and functionalities for tasks such as loading and configuring langchain models, defining Prompty chains, and executing these chains with relevant input data. This allows users to focus on the specific business logic of their applications rather than the technical details of integrating these frameworks. Inputs. Prompty configuration. This refers to the configuration settings that define the structure and behavior of Prompty chains. These settings might include aspects like the type of conversation flow, the way messages are handled, the choice of language model, and other parameters that customize the conversational experience. For example, one might configure Prompty to use a specific langchain model for generating responses, define the format of user inputs and outputs, and set rules for how the chatbot should interact with users. Langchain models and chains. This refers to the specific models and chains that will be used within the Prompty workflows. Langchain models are pre-trained language models, such as those provided by OpenAI, Google, or Hugging Face, which can perform various natural language tasks like text generation, translation, summarization, and question answering. Langchain chains, on the other hand, are sequences of steps that define how these models are used to process inputs and produce outputs. These chains might involve steps like retrieving relevant information from a database, passing the retrieved information to a language model for analysis, and then presenting the results in a structured format. For example, one might create a chain that uses a langchain model to summarize a document and then use Prompty to present the summary to the user in a conversational manner. Outputs. Formatted output. This refers to the processed output generated by the Prompty chains, which has been formatted according to the specified configuration settings. The formatting might involve aspects like the structure of the output, the inclusion of specific information, and the overall presentation style. For example, a Prompty chain might process a set of news articles using a langchain model and then output a concise summary in bullet points. Prompty output. This refers to the final output generated by the Prompty chains, which might be a message to be displayed to the user or a piece of information to be further processed by another system. The Prompty output will be based on the processed information from the langchain models and the specific configuration settings of the Prompty chains. For example, a Prompty chain might generate a summary of a news article and then use the summary to answer a question from the user. Steps. Initialize Prompty. This involves setting up the Prompty environment, including loading any necessary configuration settings and creating the required objects, such as the conversational flow and the message handling system. This step ensures that Prompty is ready to process user inputs and interact with langchain models. For example, one might initialize Prompty by loading a configuration file that specifies the type of chatbot, the language model to be used, and the rules for handling user inputs. Load langchain models. This involves loading the desired langchain models into memory, making them available for use by Prompty chains. This might involve specifying the model type, loading weights from a file, or connecting to a remote API. This step ensures that the chosen models are ready to perform the desired tasks within the promptee. Workflows. For example, one might load a pre-trained text summarization model from Hugging Face, making it available for use in a promptee chain that summarizes news articles. Run promptee chains. This involves executing the defined promptee chains, which process the input data, interact with the loaded langchain models, and generate the formatted output. This step represents the core functionality of the library, where the defined workflows are executed to achieve the desired text processing objectives. For example, one might execute a promptee chain that retrieves information from a database, passes the information to a langchain model for summarization, and then displays the summary to the user in a conversational manner. Prerequisites. Promptee installation. This involves installing the promptee library using the pip package manager. The installation command pip install promptee downloads and installs the necessary files and dependencies, making the library available for use in your Python environment. This step ensures that the promptee library is installed and ready to be used in your projects. Langchain installation. This involves installing the langchain library using the pip package manager. The installation command pip install langchain downloads and installs the necessary files and dependencies, making the library available for use in your Python environment. This step ensures that the langchain library is installed and ready to be used in your projects. Fine-tune parameters. Promptee configuration. This refers to the adjustable settings that control the behavior and functionality of promptee chains. These settings might include aspects like the type of conversation flow, the way messages are handled, the choice of language model, and other parameters that customize the conversational experience. For example, one might fine-tune promptee by adjusting the parameters of the language model used for generating responses, changing the format of user inputs and outputs, or modifying the rules for how the chatbot interacts with users. Langchain model parameters. This refers to the adjustable settings that control the behavior and functionality of the chosen langchain models. These settings might include aspects like the model's temperature, the maximum length of generated text, and other parameters that influence the quality and style of the generated outputs. For example, one might fine-tune a langchain summarization model by adjusting the parameters that control the length and detail level of the generated summaries, or by specifying the desired output format. Challenges and fixes. Missing dependencies. This refers to the situation where some of the necessary libraries or packages required by the library are not installed or are outdated. This can lead to errors when trying to use the library. The fix for this challenge is to install the missing dependencies using the pip package manager. This involves identifying the missing dependencies, specifying their names and versions, and running the installation command with the required packages. For example, if the library requires a specific version of the requests library, which is not installed, one might run the command pip install requests 2.28.1 to install the missing dependency. Promptee configuration errors. This refers to errors that occur when the promptee configuration settings are invalid or incomplete. These errors might be caused by incorrect syntax, missing parameters, or conflicting settings. The fix for this challenge is to carefully validate the promptee configuration settings, ensuring that they are correctly formatted and complete. This might involve reviewing the configuration file, checking for typos, and verifying that all required parameters are present and correctly specified. For example, if the configuration file specifies an invalid language model name, one might need to update the configuration with the correct model name. Langchain model errors. This refers to errors that occur when the langchain models encounter issues during their execution. These errors might be caused by incorrect model parameters, input data problems, or unexpected behavior of the model. The fix for this challenge is to carefully check the langchain model parameters, ensuring that they are correctly set and appropriate for the task at hand. This might involve reviewing the model's documentation, adjusting the parameters based on the specific input data, or troubleshooting any unexpected behavior. For example, if a langchain summarization model generates overly short summaries, one might need to adjust the parameter that controls the minimum length of the generated summaries. Output formatting issues. This refers to situations where the formatted output generated by prompty chains does not meet the desired requirements. This might be due to incorrect formatting settings, inconsistent data, or unexpected behavior of the formatting routines. The fix for this challenge is to carefully adjust the output formatting settings, ensuring that they produce the desired output structure and presentation style. This might involve reviewing the formatting routines, modifying the settings for specific elements, and addressing any inconsistencies in the output data. For example, if the formatted output is missing certain information, one might need to update the formatting settings to include the desired data elements. Prompty chain errors. This refers to errors that occur during the execution of the defined prompty chains. These errors might be caused by issues in the chain logic, incorrect interactions with langchain models, or unexpected data flow. The fix for this challenge is to carefully review and debug the prompty chains, identifying and correcting any errors in the logic or implementation. This might involve stepping through the chain execution, inspecting the data flow, and verifying the interactions with langchain models. For example, if a prompty chain fails to process specific input data correctly, one might need to review the chain logic and adjust the steps involved in processing the data. Langchain robocorp toolkit summary. Tools for integrating langchain with robocorp to build AI-powered automation workflows. These tools enable the combination of langchain's natural language processing capabilities with robocorp robust automation framework. This integration allows users to create intelligent workflows that can interact with data, extract information, and make decisions based on natural language understanding. Inputs. Robocorp robot files. These files contain the definitions of automation tasks and workflows created using Robocorp Visual Editor. They describe the steps involved in automating a process, such as interacting with web applications, databases, or other systems. Langchain model configurations. These configurations specify the parameters and settings for langchain models that will be integrated into the workflows. This includes the model type, e.g., a large language model, a summarizer, a question-answering model, the desired functionality, and any specific prompts or constraints for the model's behavior. Outputs. Automated workflows with integrated AI capabilities. The output of this toolkit is a set of automated workflows that leverage AI to perform tasks more intelligently and efficiently. These workflows can understand natural language, extract information from text or documents, make decisions based on context, and perform actions according to the provided instructions. Reports and insights generated by AI models. The integrated langchain models can generate reports and insights based on the data processed during the workflow execution. These reports can provide summaries, analysis, or predictions derived from the data, offering valuable information for decision making and process improvement. Steps. Define tasks and workflows using robocorp. The first step involves creating automation workflows. Within the robocorp environment, users can define tasks, specify the order of execution, and configure the interactions with external systems or applications. This lays the foundation for the integration of AI capabilities. Integrate langchain models into tasks. Once the workflow is defined, langchain models can be integrated into specific tasks. This involves configuring the chosen langchain model within the workflow, defining the input data for the model, and specifying the desired output or action to be performed based on the model's results. Execute the workflow using robocorp. After integration, the workflow can be executed using robocorp execution engine. This triggers the execution of each task, including those that involve langchain models, and ensures that the workflow progresses according to the defined steps. Analyze and interpret results. Once the workflow completes, the results can be analyzed and interpreted. This involves reviewing the outputs of the langchain models, understanding the insights derived from the data, and assessing the overall performance of the workflow. This analysis can lead to further optimization and refinement of the workflow and the integrated AI capabilities. Prerequisites. Robocorp environment. A working robocorp environment is required to execute the automation workflows. This includes installing robocorp and configuring the necessary settings, such as access to the robot framework, a Python-based automation framework. Langchain libraries. The langchain libraries are essential for integrating langchain models into the workflows. This involves installing the langchain package using a Python package manager and ensuring that the required dependencies are met. Fine-tune parameters. Model selection. The choice of langchain model plays a crucial role in the performance and effectiveness of the workflow. Selecting the appropriate model for the specific task requires considering factors such as the model's capabilities, its suitability for the input data, and the desired output format. Prompt engineering. Crafting effective prompts is essential for guiding the langchain models behavior. This involves designing clear and concise prompts that provide the necessary context and instructions to elicit the desired response from the model. Challenges and fixes. Model selection for specific tasks. Selecting the optimal langchain model for a specific task can be challenging. To overcome this, experimentation and fine-tuning of different models are essential. Evaluating the model's performance on sample tasks and adjusting the model parameters can lead to finding the best fit for the workflow's needs. Integration with robocorp workflows. Integrating langchain models into robocorp workflows may require custom code or adapters to bridge the gap between the two frameworks. This involves writing code to handle the communication between robocorp tasks and langchain models, ensuring that data is transferred and processed seamlessly between the two systems. Data handling and security. Managing data security and privacy is paramount when using langchain models in automated workflows. Implementing appropriate data sanitization techniques and encryption mechanisms is crucial for protecting sensitive information. This includes ensuring that data is anonymized or tokenized before being processed by the langchain models, and employing encryption methods to secure data both at rest and in transit. Action Server Request Tool. Action Server Request Tool. A tool used to send requests to the robocorp action server. This tool allows you to interact with your robocorp actions, which are reusable components that perform specific tasks. Inputs. The name of the action you want to execute. For instance, get weather data or send email. The parameters or data needed by the specific action you choose. For example, the get weather data action might require parameters like city and country, while send email could require recipient, subject, and message. Outputs. The output of the executed action, which could be data, a file, or any other result generated by the action. Steps. Establish a connection with the action server, which is a service that hosts and manages the execution of actions in your robocorp environment. Send your action request with its chosen name and input parameters to the action server. Receive the response from the action server, which includes the output generated by the executed action. This response is then processed and prepared for use by other components in your application. Prerequisites. The robocorp action server must be installed and configured correctly on your system. This service is responsible for managing and executing the actions you define. To install the robocorp action server, follow the instructions available in the robocorp documentation. Ensure the server is running and properly configured for your environment. The action server must be accessible from your application. This ensures that your application can communicate with the server and execute actions. Confirm that the action server is running on the correct port and that there are no firewall rules blocking communication between your application and the action server. Fine-tune parameters. The maximum time you allow the action server to complete the request before timing out. This prevents your application from waiting indefinitely for a response. Set a reasonable timeout value based on the expected execution time of your actions. This parameter helps to prevent issues caused by slow responses or unexpected delays. The number of times the tool should attempt to resend the request to the action server if it encounters an initial failure. This provides resilience to transient network issues or temporary server errors. Setting an appropriate number of retries helps to increase the robustness of your application and improve its handling of temporary errors. Challenges and fixes. The action server may be unavailable due to network issues or server problems. Check your network connection to ensure that you can reach the action server. Verify that the server is running and that no firewalls or other network security measures are blocking communication. An error might occur during the execution of the action, which could be caused by incorrect inputs or a problem with the action itself. Review the logs generated by the action server to identify the specific error messages. This will provide clues about the cause of the error and help you to troubleshoot and resolve a problem. Action Server Request Tool Summary. This tool enables communication with robots that are managed by an action server. It acts as an intermediary, facilitating the sending and receiving of requests and responses between the user and the robotic systems. Inputs. The name of the robot that you wish to interact with. This is typically a unique identifier assigned to the robot within the action server system. The specific action you want the robot to perform. This could be a predefined task like moving to a specific location, grasping an object, or executing a complex sequence of movements. Outputs. The response from the action server to your request. This can include information about the success or failure of the action, any error messages encountered, and status updates about the robot's progress. Steps. Establish a connection between the tool and the action server. This involves setting up a communication channel using protocols like HTTP or WebSockets, and authenticating with the action server. Transmit your request to the action server, including the target robot and the desired action. The tool should format this request according to the action server's API specifications. Receive and interpret the response from the action server. The tool should handle any error conditions or unexpected responses, and provide meaningful feedback to the user. Prerequisites: the URL of the action server. This is the address where the action server is running, allowing the tool to locate and connect to it. This is a web address that identifies the location of the action server. It might look something like https://actionserver.example.com. Credentials for accessing the robot. This typically involves authentication information like a username and password or an API key, allowing the tool to verify your identity and gain permission to control the robot. These credentials are necessary to authorize your requests to the action server, ensuring that you are authorized to control the robot. They may be provided by the system administrator or generated by the robot itself. Fine-tune parameters. The maximum time the tool should wait for a response from the action server before considering the connection lost. This helps avoid hanging issues if the server is unresponsive. This parameter defines how long the tool will wait for the action server to respond before considering it unreachable. A longer timeout allows for more time for the server to process the request, but can also make the tool less responsive. The number of times the tool should attempt to re-establish the connection to the action server in case of failure. This ensures that the tool can handle temporary network disruptions. This parameter allows the tool to retry connecting to the action server in case of initial failure. Multiple retries increase the chance of a successful connection, but can also slow down the overall process. Challenges and fixes. The action server may be unavailable due to network problems, server downtime, or other technical issues. This can happen if the server is experiencing a temporary outage or if the network connection between the tool and the server is interrupted. To fix this, verify that the server is running and that your network connection is active. You may lack the necessary permissions to access the robot. This could happen if your credentials are invalid, expired, or if the system administrator has restricted access to the robot. To fix this, ensure that your credentials are correct and that you have the required authorization to control the robot. Langchain robocorp toolkit run details callback handler summary. Detailed description of the langchain robocorp toolkit run details callback handler. This callback handler logs and tracks the execution details of robocorp tasks using the langchain library. It effectively bridges the gap between the operational world of robocorp and the analytical power of langchain, providing rich insights into task execution. Inputs. Details about the robocorp task being executed. This can include information such as the task name, input parameters, start time, and other relevant metadata. For example, a task might involve processing a batch of customer data, and the input could include the file path of the data, the processing parameters, and the expected output format. Outputs from the langchain models used in the robocorp task. These outputs could include text summaries, classifications, code generations, or any other result generated by the langchain models. This information provides context and insights into the reasoning and decision-making process of the langchain models during the task execution. Outputs. Formatted task execution details. This output provides a comprehensive report summarizing the task execution, including the task name, input parameters, start and end times, execution status, and any encountered errors. This information allows for efficient monitoring and troubleshooting of task execution. Logs and insights from langchain model interactions. This output provides a detailed record of the langchain model interactions during the task execution. It captures the prompts used, the model outputs, and any relevant metadata associated with the model interactions. This information helps in understanding the reasoning behind the model's decisions and enables further analysis of the model performance. Steps. Initialize the callback handler. This involves setting up the callback handler with the necessary configuration, such as the logging level, output format, and any specific customizations. Track the task execution details. This involves recording the start time, input parameters, and other relevant metadata associated with the task execution. The callback handler monitors the progress of the task and logs any significant events or milestones. Record langchain model outputs. As langchain models execute during the task, the callback handler captures and records the model outputs. This ensures that the insights generated by the models are documented and available for later analysis. Generate and format reports. Based on the captured task execution details and langchain model outputs, the callback handler generates comprehensive reports summarizing the task execution. These reports can be customized to provide different levels of detail and focus on specific aspects of the task execution. Prerequisites. Langchain library installed. The langchain library provides the necessary functionalities for interacting with and utilizing various large language models. This is a core dependency for the callback handler to function properly. Robocorp task definition. This includes the definition of the task, its inputs, outputs, and the logic for its execution. The callback handler integrates with the robocorp task execution framework to capture and log relevant details. Fine-tune parameters. Log level for detailed tracking. This parameter controls the level of detail in the logs generated by the callback handler. It can be set to different levels, such as debug, info, warning, or error, to adjust the amount of information logged. Output format customization. This parameter allows for customizing the format of the generated reports. Users can specify the desired output format, such as plain text, JSON, CSV, or HTML, to tailor the reports to their specific needs. Challenges and fixes. Callback handler failure. The callback handler might fail to capture task execution details or model outputs due to various reasons, such as network connectivity issues, unexpected errors during task execution, or limitations in the callback handler implementation. Handle potential errors and log them. The callback handler should implement robust error handling mechanisms to capture and log any errors that occur during its operation. This helps in identifying and troubleshooting potential issues with the callback handler. Missing task details. The callback handler might not be able to capture all the necessary task details, potentially due to missing information in the task definition or limitations in the task execution framework. Implement error handling and provide informative messages. The callback handler should implement mechanisms to identify missing information and provide informative error messages to the user. This helps in understanding the limitations of the callback handler and addressing any potential data gaps. Tool input schema summary. A description of the tool input schema for the langchain robocorp toolkits. Inputs. The name of the robot to be used for automation. This name could be a descriptive identifier for the robot, such as sales order processor or inventory management robot. It could also be a more technical name reflecting the robot's functionality, like robot order processing or robot inventory control. The version of the robot being utilized. This indicates which specific release of the robot is being used, and may include information like bug fixes, performance enhancements, or added functionalities. For example, Versions could be 1.0.1, 2.2.3, or 3.0.0 beta. Outputs. The results produced by the robot during its execution. This output could be in various formats, depending on the robot's purpose. For instance, it could be a structured data file, a text report, a collection of images, or a combination of these. Logs generated by the robot throughout its execution. These logs are valuable for debugging and understanding the robot's behavior. They typically include information about the steps taken, any encountered errors, and other relevant events during the robot's operation. Steps. Install all the necessary software packages required for the robot's operation. These dependencies could include libraries, frameworks, and other tools specific to the robot's functionality. This step ensures the robot has all the required components to run smoothly. Establish a connection between the tool and the robot. This ensures communication and data exchange between them, allowing the tool to send commands and receive responses from the robot. The connection method could be through a network protocol, a file system, or another communication mechanism. Execute the robot to perform the desired automation tasks. This involves launching the robot and running its defined workflow, allowing it to interact with systems, gather data, process information, and complete assigned actions. Prerequisites. The environment required to run the robocorp robot. It could be a cloud-based platform or a local machine. RoboCloud, a cloud-based platform for managing and deploying robots, provides a convenient and scalable environment for running robots. Local installations refer to setting up the necessary software and configurations on a physical machine to run the robot. This might involve installing a specific version of Python, the robocorp runtime, and any other required tools. The programming language used by robocorp, which is Python. This version is required to ensure compatibility with the libraries and tools used by the robocorp. Robot. Pip is a package installer used in Python for managing external libraries and tools required for the robot's operation. It allows you to easily install, update, and uninstall packages. Virtualev is a tool that creates isolated Python environments. This helps prevent conflicts between different projects by ensuring that each project has its own set of installed packages and dependencies. Fine-tune parameters. Arguments or parameters that are passed to the robot during execution. These parameters can be used to modify the robot's behavior and functionality, allowing for customization and flexibility. For example, you could provide the robot with specific file paths, search criteria, or target systems. The configuration settings for the robot. This includes defining how the robot should operate, such as its default settings, data sources, and communication protocols. The configuration settings can be modified to adjust the robot's behavior and functionality to specific needs. Challenges and fixes. Issues encountered when trying to connect the tool to the robot. These could be due to network problems, incorrect configurations, or issues with the robot's status. Verify the network connection between the tool and the robot to ensure they can communicate properly. Check for network connectivity issues, firewall blocks, or incorrect network settings. Ensure the robot is in a state that allows connections. Check if the robot is running properly, if it's accessible on the network, and if any security settings are preventing connections. Errors that occur during the robot's execution. These could be due to code errors, unexpected inputs, or issues with the robot's logic. Review the logs generated by the robot to identify the cause of the errors. Logs provide detailed information about the robot's execution, including error messages, stack traces, and other valuable debugging information. Debug the robot's code to identify and fix any errors or logical flaws. This may involve inspecting the code for syntax errors, logic errors, and other potential issues. Problems encountered when trying to interpret the robot's output. This could be due to inconsistencies in the output format, missing data, or unexpected data structures. Adjust the output parsing logic used by the tool to accommodate the robot's output format. This may involve modifying the code that processes the robot's output to handle any variations or inconsistencies. Review the robot's output format to ensure it aligns with the expected data structure. Verify the data types, structures, and any special conventions used in the robot's output.